abstraction of backtrack approach. Hmm. So now we want to discuss a control abstraction or general method or control abstraction of backtracking approach that we want to discuss. So here this is the next topic. Okay. General method or control abstraction of backtrack approach. Okay, this is the next topic. So first we will assume. So this is an algorithm. I'll show it that we want to discuss this approach. Okay, this is the algorithm for or general algorithm for backtrack, and here first we assume that all answer nodes are to be found. First we will assume we want to find all answer node. Okay, we want to find all answer node. So we want to find all answer nodes are to be found. Then let x1, x2, etc. xi is a path from the root to a node in the state space graph. Next we will assume x1, x2, etc. xi. Okay, xi is a path from the root to a node in the state space graph. Okay. Basically a node I, root to the node I in the state space graph. Then let it t of x1, x2, etc. xi be the set of all possible values for xi plus 1. Then what is t means? T of x1, x2, etc. xi means the set of all possible values for xi plus 1. Then we will assume such that x1, x2, etc. xi plus 1 is also a path to a problem state. Then this is the next assumption. Then we will take b. B means the constraint function or boundary function. Okay. Let bi plus 1 is the boundary function. Boundary function. What is the use of boundary function? It is used to implement the constraint in that problem. So let bi plus 1 is the boundary function. Then if bi plus 1, x1, x2, etc. xi plus 1 is false for a path x1, x2, etc. xi plus 1 from the root node to a problem state, then the path cannot be extended to an answer state. So you can observe this. This is another assumption. Okay. So what is bi plus 1 means? It's the boundary function of the I plus 1 node, and if it is false for a path from x1 to xi plus 1 from the root node to a problem state, then the path cannot be extended to an answer state. This is another assumption. Next, this is the backtrack approach algorithm. In the backtrack, this is a recursive algorithm, and this describes the backtracking process using regression. On entering first k minus 1 values x of 1, x of 2, etc., x of k minus 1 of the solution vector, it's already assigned k minus 1 values in the solution vector. Then this is the basic process. For each x of k belong to t of x of 1, etc., x of k minus 1. First, we will check if bk of x1, x2 not equal to 0, then we will add that path to the answer node. This is the basic control abstraction. Then write this: if k less than n, then backtrack with k plus 1. K plus 1. This is the basic control abstraction of solving a backtrack approach based problem. So, uh, so this control abstraction is important. It's an important topic. So, okay. So next we can focus on the NQ's problem. Next, we can focus on the NQ problem. After discussing the NQ problem, we will come back. We will discuss the backtrack approach again. Okay. So then only I think I will get an idea about this algorithm. So anyway, I'm just next time discussing this NQ problem and how we can solve NQ problem using the backtrack approach. After that, I will come back to the. I will discuss this abstraction, control abstraction. Okay. So now, what is NQ's problem? Already we know what is NQ's problem means. There are NQs and a chessboard and a chessboard. There is a n by n chessboard and n queens are there. Then we want to arrange the n queen in such a way that they will not attack each other. So okay, so this is the constraint involved in that problem. That is, so that no two keys are on the same row, same column, or diagonal. We want to arrange the keys by satisfying in such a way that that will satisfy this condition. So now we are discussing n-queen problem using backtrack approach. So what is n-queen problem? N-queen problem means there are n queens and we want to place the n queens in an n by n chessboard in such a way that they will not attack each other. And for such an arrangement, this is the condition, so that no two queens are on the same row, same column or diagonal. This is the condition for not attacking each other. So this is about the n-queen problem. This is n-queen problem. N-queen problem. Then there is what is 8-queen problem. 8-queen problem means there are 8 queens and we want to place 8 queens in a 8 by 8 chessboard in such a way that they will not attack each other. That is the 8-queen problem. Okay, that is the 8-queen problem. And then what is 4-queen problem? There is a 4 by 4 chessboard and we want to place 4 queens in such a way that they will not attack each other. That is 4 queens problem. Okay. So in this class, already I told this control abstraction I will discuss later. Okay, then only you will get an idea. After discussing or solving this type of problems, n-queen problem, etc. problems, only we can discuss this algorithm in detail. Okay, so I am just leaving that topic now. I will come back to this point later. Okay, so Anyway, now I am focusing on what is NQueen problem, how we can solve the NQueen problem. Okay. So what is NQueen problem discussed? Then what is 8 problem means there is a chessboard of size 8 by 8. We want to arrange the 8 queens in such a way that they will not attack each other. Okay. So uh, next is 4 queen problem. What will be the 4 queen problem? There is a 4 by 4 chessboard and we want to arrange 4 queens in such a way that they will not attack each other. Okay, that is 4 queens problem. Okay, so this is a chessboard and we want to place 4 queens. For example, suppose I am placing q1 here. uh, Then suppose I am placing q2 here. Then q3 here. Suppose I placed q4 here. But in this case, these 2 queens will attack each other. Okay, or this will attack each other. So I want to place queens in such a way that they will not attack each other. For example, I will show an arrangement. This is an arrangement. I am placing q1 here, then q2 here, then q4 here, and q3 here. Okay, so they will not attack each other. I want to find such an arrangement. Okay, that is called 4 by 4. This is one solution. This is one solution. Q1 I am placing here, Q2 here, Q3 here, Q4 here. So in this case, they will not attack each other. So I want to find out uh, this solution using the backtrack approach. Okay. So I hope you got an idea about what is a 4 by 4 problem and how can solve 4 by 4. Okay. This is one solution. As I told earlier, it is not a solution because if I placed it in this way, they will q1 will attack q3, q4, and q4 will attack q3. Okay, they will attack. It is not possible, so it is not a solution. Okay, I want to find a solution in this way. Okay, this is a good solution. Okay. So how can find such a solution using backtrack approach? That I want to focus. Okay. So what I am doing is that first I will take some assumptions and I will define the solution vector. Okay. As already told, it is a 4 by 4 chessboard, and next what I am doing is that I will take some assumption. Okay. So I'm defining the format of the solution vector. Okay. So the solution vector I am defining in this way. There is X. X is an array and there are 4 places or 4 positions and numbered 1, 2, 3, 4. And I defined the format of the problem in this way. Solution vector. I defined the solution vector of this problem in this way, and I will take some assumptions. Okay, so uh, I will take this assumption. Okay, I will take this assumption. That is, we will place first queen in the first row, second queen in the second row, third queen in the third row, fourth queen in the fourth row, and so on. Okay, so is the okay. Uh, so this assumption is very important. Okay, so uh, I'm trying to solve the 4 by 4 chain problem, 4 chain problem. So I define the solution vector format in this way, and then I take an extra assumption. So which means q1 will be always placed in the first row. Okay, you can note here, if this row, in this row only I will place q1. Okay, in this row only I will place q1. In the second row I will place always q3 only. It is reserved for q2. Sorry, q2. Okay, third row is for q3 and so on. Okay, so if I taken this assumption, for example, uh, if I taken this assumption, then I can define the solution vector format in this way. Okay, and because of this assumption, I am defining the solution vector in this format. Okay, what is this format? For example, this is an array. These are the column numbers. Okay, this is column numbers. This is first column. This is second column number. This is third column number, and fourth. So we will place first key in. Okay, so this is column number 1, 2, 3, 4. Then what is its meaning? For example, x, here I am placing q1 in the first column. What its meaning? What its meaning? Q1, you can observe in the solution vector. For example, in the first column I return q1. What is its meaning? q1 is placed in the first column of first row. Okay, this is implicit. Okay, q1 always placed in the first row only. But if I placed q1 here, then its meaning is q1 is placed in the first row of first column. So I will place q1 here. Okay, this is the meaning. Okay, okay, this is very important. Okay, q1. Okay, similarly, suppose I return q1 here, then what is its meaning? This is in second column. q1 comes in the second column. Then it will q1 always will be in this row only. Okay, and it is I return q1 in the place 2 means it will come here. Okay, q1. Okay, so in that way I defined the solution vector. Okay, so I defined the solution vector in this way. I taken this assumption, then I defined the format. So this is a one dimensional array. Okay, so next I want to solve this problem using the backtrack approach. Okay, so as I already told you, we will try to find out a state space tree, or we will try to create a state space tree in an optimized way. Okay, in addition, you can note here, for solving this problem, we are using a bounding function. Okay, which is the bounding function used to solve this problem? That is, two queens should not attack each other. So what is the bounding function in this problem? So queens should not be in the same row, same column, or same diagonal. Okay, this is the bounding function. Okay, so this is also important. So we defined what is 4x4 problem, what is the bounding function, and what is the solution vector format. Okay, so next we are trying to solve the problem. Okay, so first we will start from the initial state. From the initial state, what we will do? We will place q1 at position x1. Okay, at position x1 I will place q1. Okay, so next I reach at this state. Okay, then what I will do, this is backtrack approach. Okay, this is backtrack approach. Then from this, before creating the next node, I can create this node. Okay, next what I have done is that I return, so I return in this way. This is solution vector. Here I placed q1. Q1 I placed here. Hmm. Next, here I will place q1 here. Then on the next position I will place q2. Next position I will place q2. Then I reach at this state. Then I will try. Then at this state, what I will do? Before creating the next node, I will check whether these two are acceptable or not. Whether these two are acceptable or not. That means first I placed q1 here. Q1 here. Then I placed Q2 here. Q2 here. Then before placing the next node Q3, I will check whether this solution is okay or not. This solution is okay. This will be in diagonal, so they will attack each other. So this is not possible. So what I will do? I will stop here. So I stopped the process here. Okay. So next what I will do, I will backtrack to here. Then I will try another alternative. Okay. I will try to place Q3 at the second position. At the second position, I will place Q3. That is, I will place Q1 here. Then I will place Q3. Q3 always I will place here. Q3 I will place here. Okay. Then I reached here. Okay. I reached here. Then before creating the next, then I will place Q2 at the third column. I will place Q2 at the third column. So I will place Q2 here. Q2 here. And next I reach this state. From this state, before creating the next node, I will check whether this solution from this solution is acceptable or not. So I placed in this way. Here they will attack each other. So this solution is not possible. So what I will do? I will stop here. I will stop here. So that is not possible. That is not a solution. Then I will try another alternative. So then I will try this one. That is, I will place Q4 at the third column. Q4 at the third column. That is, I will place Q1 I placed here. Then where I placed Q2, Q2 I placed at the position column 3. Q2 I placed at the position here. Then Q3 I will place here. Then what I will do, in the third column, I will try to place Q4. I will try to place Q4 in the third column. So third column means this. Okay. Here I will place Q4. Here I will place Q4. Then what I will do, placed here, then before creating the next node, then I want to place Q2, but before creating that, I will check whether this solution is acceptable or not. But here they will attack each other. They will attack. So it is not possible. So I am stopping here. This is also not possible. Then I will backtrack. Then I will backtrack to this point. Then I will try another path. This path. So Q1 is 1. Q1 here. Then what is Q2? Q2. X2 is equal to Q4 means in the second column I will place Q4. Then I will try that. So in the second column I will place it Q4. Second column I will place Q4. So Q1 is here. Then on the second column I will place Q4. I will place Q4 here. Then what I will do is that I reached here. Then I place in the third column I will place Q3. In the third column I will place Q3. Place Q3 in the third column. So Q3 will come here. Then Q3 comes here. And next I want to place Q2. So I will try to place Q2. But before placing Q2, I will check the solution up to this point. Is acceptable or not? But here they will attack each other. So that path also not possible. That is also stopped. In this way, I will try all ways, all path. This is also I will check, and this is also fail. This will also fail. Okay. Then I will backtrack and I will go back to here. Then I will place x1 equal to q2, which means in the column 1 I will place q2. So I will place Q2 in the column 1. Okay, which means Q2 I will place here. I will place Q2 here. That is this path fully failed. This path is fully failed. So what I will do is that x1 equal to Q2. I will place Q2 in the column 1. Q2 in the column 1. So it will always comes here. Then I will place, I reaches here. From that I can place the second column I can fill with Q1, Q3 and Q4. So first I try this one. So I place Q1 in the second column. So I will place Q1 in the second column. So I will place Q1 here. So next what I will do, I will try to place Q3. I will try to place Q3, but I will try to place Q3, but what will happen? It is not possible. Okay, because these will attack each other. This will attack each other. So that path is not possible. So I will end that process. Here I will end. Similarly, I will end here. Then I will go back. Then I will try Q3. This is also not possible. Then I will try Q4. Then I will try Q4 here. Then I will place this. Then I will place this. So this is the only solution path. If I placed in this way, I can clearly place all. So this is the order: Q2, Q4, Q1, Q3 in these positions. If I place in this way, I can fill all in such a way that they will not attack each other. They will not attack each other. And this is the solution path. This is the solution path. So this is about the solving an queen problem using the backtrack approach. I will discuss more details in the next class. Okay, thank you. Please give your attendance in the chat box. Okay. Okay, thank you. Thank you. Okay, thank you.
മതി സാറേ, ഞാൻ റെക്കോർഡ് സ്റ്റോപ്പ് ചെയ്യണേ.